Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In electrophilic aromatic substitution, nitration with HNO3H2SO4 alkyl groups are ortho-para directors. The ortho-para OP ratio depends on the steric bulk of the substituent R on the benzene ring. A bulkier group at R shields the ortho positions, which are adjacent to R, more than the para position, which is far from R, thereby reducing ortho product formation and lowering the OP ratio. Conversely, a smaller, less sterically demanding group allows easier access to both ortho positions, giving a higher OP ratio. Moving on to the next step. Identify the steric bulk of each substituent. A. R is equal to CH3, methyl least bulky, minimal steric hindrance at ortho positions. B. R is equal to CH to CH3, ethyl slightly more bulky than methyl. C. R is equal to CHme2, isopropyl more bulky than ethyl. D. R is equal to Cme3, tert-butyl most bulky, maximum steric hindrance at ortho positions. Moving on to the next step. The smaller the substituent, the less it blocks the ortho positions, so more ortho product forms relative to para product, giving a higher OP ratio. As steric bulk increases from CH3CH to CH3CHme to Cme3, the ortho positions become increasingly hindered, and the OP ratio decreases. And for the final step, determine which gives the highest OP ratio. R is equal to CH3, methyl, is the smallest substituent and causes the least steric hindrance at the ortho positions. Therefore, the proportion of ortho product is maximized relative to para product, giving the highest OP ratio among the four options. Why other options fail? B. Ethyl is bulkier than methyl, so OP ratio is lower than for methyl. C. Isopropyl is even bulkier, further reducing the OP ratio. D. Tert-butyl is the bulkiest, giving the lowest OP ratio, mostly para product. Therefore, the correct answer is A. Therefore, the correct answer is option A.